So integral properties, there are three of them. First one, you have your integral from a to a, f of x dx. And what I mean by that is your lower boundary and your upper boundary are the same number. So instead of having an interval from like 1 to 7, it would be like from 1 to 1. How much area could be under that graph if your interval doesn't go anywhere? Yeah, nothing. You accumulated no area. You want to think of it as an accumulation, like from here to here, or like a journey. I went from here to here. You didn't go anywhere. So you got precisely nothing. Cool? These are all pretty intuitive, right? Next one, if you go from a to b, integral from a to b, and these all have f of x dx. Again, f of x represents the height. dx represents the base of your rectangles. It's base times height. They're all areas is what we're doing. That equals negative integral from b to a, f of x dx. Do you see what I did there? I put a negative, and then what did I do with the boundaries? You flip them. I think of that like a road trip. If I go from point A to point B, when I turn around, I go from point B to point A, just the other way. Again, these all kind of make sense, right? And then the third one, integral from A to B, again, f of x dx, plus integral from B to C, f of x dx, equals, what do you think? You go from A to B, and then you go from B to C, from A to C. I think of it like a road trip. You went from A to B and did kind of like a rest stop, and then you went from B to C. So your whole trip is from A to C. Again, that should like logically make sense. It all kind of makes sense. So we're going to use those properties to answer these couple of questions here. And we're given this information. All of these boundaries are from 3 to 6. For your x squared, you get 63. For just x, you get 13.5. Do you see how this one looks like there's kind of nothing there? It's really a 1, if you want to think of a 1 being inside of that. That gives you 3. Again, those represent areas. Do you remember me coaching you on and just saying this repetitively? Derivative means slope. Integral means area. That's what you want to think of it. Derivative means slope. Integral means area. I'm gonna just drill you on it. We're gonna say it over and over again. All right. So those represent the areas under the graph. So what did we do with the boundaries on A? Instead of 3 to 6, now it's 6 to 3, and it's with the x squared. So you're looking at this one. So any thoughts? What do you think? Just negative 63. You just went the other direction. This one, I'm going to break into 3 separate integrals so that you can see where this comes from. You might be able to do it without this step, but I want you to understand what's going on. Do you see how instead of just x squared, it's 2x squared? You're allowed to take the coefficient and bring it out front of the integral. You can't do that with a variable, though, only a number. So don't do that with a variable. That's not allowed. All right, but do you see how I just took the 2 and put it out front? X squared dx. Minus 5 integral 3 to 6 of just x dx. Do you see how I'm just kind of breaking it all apart? So you can understand where each part comes from. All right, plus 4 integral 3 to 6 of just dx. Or again, if it bothers you that it's empty, because that happens sometimes, people are like, I don't like this. You can put a 1 in there. If you're like, oh, it really bothers me that there's nothing there. You can put a 1 inside of there. So then when you go to figure out what this actually equals, for this first part, you would have 2 times what? What does this part equal? 63, good. Minus 5 times, yep, this part is 13.5. It's just given in the problem. Plus 4 times 3. And we did enough of that on the warm-up, so I'm not going to make you actually work that out by hand. We'll just leave that answer as is. All right, so down here, we're gonna need to find our areas on this graph before we do anything else. So you're gonna need to know how to find areas of basic shapes. And when I say basic shapes, the ones you're gonna need to know are triangle. So what's your area formula for a triangle? 1/2 base times height, rectangle, which is just base times height, a trapezoid, which is what? 1/2 height, base 1 plus base 2, and semicircle. What's a whole circle? Oh, we're not doing, no, but that's unit circle. I'm glad you're thinking about that. But I mean area. So what is a whole circle area? Thank you. Pi r squared. So a semicircle would be half of that. So it would be 1/2 pi r squared. There, we got there. Okay. So for this first one, what shape have we got? Triangle. So off to the side here, I'm going to write 1/2 base times height. What is the base of that triangle? 5. Good. And the height? 4. Good. So altogether, 10. Perfect. All right, here we have a semicircle. So it's 1/2 pi r squared. R is the radius. So that's from the center out to the edge. So what is the radius of that semicircle? 3. So 3 squared is 9. It'd be 1/2 times pi times 9. I think the easiest way to write that would be 9 pi over 2. But it is actually negative 9 pi over 2. Why is it negative? Underneath, below sea level. If you want to think of like accumulation, it's a de-accumulation. It's like money out of the bank, okay? Below sea level. And then lastly, we have this little guy, so another triangle. So 1/2 base times height. The base is 1, the height is 2. So 1. Now, when we have all those, we're just going to use them to answer these questions. So look at letter A. Integral from -5 to 0. So you're going from here. You kind of have to watch me point to it, which is great because it's like, hey, look, this is what we're doing. You're going from here to here. So you're accumulating area from -5 to 0. Well, that would just be what? Yeah, 10. Don't overthink this. We already found a lot of the answers. All right. Letter B, from 0 to 6. Yeah, negative 9 pi over 2. What if it was from 6 to 0? What if you went from here to here and you were going backwards? What do you think? Yep, positive 9 pi over 2 is what that would be. Sorry, that was just a follow-up question. All right, from 6 to 7 is just 1. Perfect. Now we're going to start putting them together. From -5 to 7. So that's from the beginning here all the way to the end. So you're going to add all of the accumulation together. So it is going to be 11 minus 9 pi over 2. Where did I get 11 from? Like, how did I get that? Yeah, 10 plus 1 is all we did there. This is the exact same question, except absolute value. What's that going to do to all your areas? Yeah, make them all positive. So instead of 11 minus 9/2 pi, it's going to be 11 plus 9/2 pi. Yeah, don't overthink. It's just absolute value makes it all positive. And then this one, we're going from 0 to -5. So again, watch me point. 0 is right here. We're going from 0 to -5. So we're going this way. So -10. We went from here to here. So it's this triangle, but we went backwards. These are the exact same thing, but you don't have a picture, so you're going to have to draw one. We want the area under this graph from -2 to 4. Again, we're going to just do this over and over again. Derivative means slope, integral means area. Good. Okay, we're going to do it over and over again. So we're going to draw this graph, just kind of give yourself a little space here. And we want the area underneath of it from -2 to 4. Well, that's a line. This is kind of like welcome back to Algebra 1 class. You would start at 2, that's your y-intercept, and then your slope is a half. So up 1 over 2, up 1 over 2. I know we don't have a grid, so it's kind of like just do your best. So there's that line, and we want the area from -2 to 4. So here is -2. Here is 4. This is the area that we're finding. And so what shape is that we ended up with? It is a trapezoid. Perfect. It's on its side. This would be the trapezoid if it was right side up. This is the height, and then this is base 1, and this is base 2. All right. So how do you get your area of a trapezoid? You guys told me before lunch. We'll just review it again. 1/2. Cool. Height, which in this case is this distance. This is your height. So how far is that? So 6. Good. And then we're going to add the bases together. So this first base is just 1. And then this one, what is that, 4? I know sometimes it's hard without a grid. So what does that all shake out to? That'd be, yeah, this would be 3. Half of 6 is 3 times 5, so 15. Cool. This is an absolute value, so it's going to be a V shape. And we want the area underneath of it from -3 to 0. So here's what I would do. I would plug in -3, and I would plug in 0, and then I would also get the point of the V shape, which as a heads up does not land on a nice whole number, so this is going to involve fractions. It's not as bad as the warm-up one we did, though. It'll be okay, right? So we're going to plug in our 2 boundaries, and then we're going to get the point of the V shape. So if you plug in -3, I'll talk you through it. 3 times -3. -9 plus 4, -5, but absolute value that 5. So we get -3, 5. If you plug in 0, you would just get 4. And then the center, it's where it's going to hit the x-axis. You get that from setting this equal to 0. If you set 3x plus 4 equal to 0, what are you going to get? Where is this going to hit the x-axis? It's a fraction. Yeah, -4/3. Now that's -1 1/3. So that would be like right about there. And so this is the V shape, our absolute value. And we want the area underneath of it from -3 to 0. So you end up with these 2 like lopsided kitty cat ears is what it ends up looking like. So there's going to be 2 areas added together, and they're both triangles. So again, triangle is 1/2 base times height. We're just going to do the first one plus 1/2 base times height for the second one. And they're just going to involve fractions, but it's going to be okay. So base of this first one, well, from here to here is 1. And then from here to here is 2/3. How did I get that? Why is this amount 2/3? Because there's 1/3 left. We were at -4/3 for that. So 1 and 2/3. What would that be as just like a single fraction? Because I don't want it to be a mixed fraction. 1 and 2/3 be 5/3. Good job. See, we made it through. And then what's the height of that one? 5. So this one over here, again, if you watch me point to it, this is 1 and then and 1/3. So good, thank you. 4/3, perfect. And then the height of that one is 4. And we'll fight our way through it. Again, it's not as bad as the warm-up one that we did. This one's not too terrible. When you do the numerators here, 5 times 5, 25. And then what would your denominator be? Yeah, 6, good. Plus, this one would be 4 times 4 gives you 16, 6. And then you would just add those together. What is that? 41, 6. So integral means area. It's the area under the graph. I think those were all the area ones. Good. Okay. The other topic that we're doing today, actually, I'll get to it in a second. With your group really quick, I'd like for you to find the derivatives of each of these. Just go ahead and do that and compare with your group. We're going to find the derivatives of A, B, and C. What'd you end up with? Yeah, for all of them, right? Why'd they all come out the same? The first two terms are the same. Are they all the exact same problem though? No. A constant goes away. The derivative of a constant is zero. You can think of a constant graph, the slope is zero. What we're going to do is call it an antiderivative, and it is exactly what it sounds like, is where you go backwards. But you always have to add a constant to the end to take care of the fact that there might be a number added or subtracted at the end. So an antiderivative is an inverse of a derivative. I actually really like teaching this. This is fun because after we do a few, everybody starts to get the hang of it and we can kind of roll through them and it's nice. Everybody's like, oh, I get this. Inverse of a derivative. So it's going to look like this. You have your integral symbol. And inside of there, you have f prime. If you go backwards, do you remember how we did like position, velocity, acceleration, and you kept taking a derivative? If you go backwards, it's an antiderivative. So if you do the integral of f prime, you just get f of x. But you have to put plus c, plus a constant, in case if it's plus 1,000,000 or plus pi or plus negative 5,000. Like there can be a number there. Now these are called definite integrals. They have boundaries and you have to understand the difference between these. It's simple, but you got to get this. This is a definite integral. This is called an indefinite integral. Because it doesn't have boundaries. If there are no boundaries, you can't find the area because you have no starting and ending place. So it's just an indefinite integral. It's an antiderivative. All right, here we go. You need to come up with a function that if you did the derivative, this would be your answer. It's like Jeopardy. This is the answer and you want the question. Can you come up with a function that if you did the derivative, you would get zero? Like zero is the answer. 4. Or what else? 5. Like just a number, right? So just C. Any number, if you did the derivative, you would get 0. This one's a little bit more interesting. You need a function that if you did the derivative, you would get -3. -3 is the answer. I need the problem. Oh, you guys even said plus C. That's usually, everybody forgets that. -3x plus 10, -3x plus 4,000,000. It's -3x plus C. Cool. How about antiderivative of 5? You need a function that if you did the derivative, you would get 5. 5 is the answer. Good. Now I threw a variable in there. I don't want to tell you because you guys will remember this better if you think it through yourselves. And you're all very smart. You can come up with it. I need a function that if I did the derivative, I would get x. X is the answer. Think about it. You can talk to each other too. You'll come up with it. There needs to be a squared, but the derivative of that would be 2x, and I want it to just be x. Well, we would put the 1/2 just out front. 1/2 x squared. If you did that derivative, when you bring the 2 down, the 2 and the 1/2 would cancel, it'd be gone, and then when you subtract 1, you would get just x. Plus 10x plus c. Good job. How about this one? I need a function where x cubed is the answer. Nice job. Plus c. Do you remember in a lot of problems that I gave you, there was a 1/5 x to the 5th and a 1/4 x to the 4th? That's because what I did is I figured out what I wanted your answer to be, and then I did an antiderivative, and that's what I gave you as the problem. That's what I did to make up those questions, okay? For this one, I would ignore the 1/3 for a second. Just ignore it. Pretend it's not even there. You can do that with a number. You can't do that with a variable. Just do the x to the 5th part. What would be the antiderivative x to the 5th? Good. Plus c. And then what I would do is just put the 1/3 back. And I'm going to flip my pencil over. There's a cool thing on the other end, which is an eraser. And I'm going to just fix that. 1/3 times 1/6 be 1/18. And you can always do the derivative to check. If you do the derivative of this, you'll get 1/3 x to the 5th. So you can always do a derivative to check. All right, what do you think for 12? Just do it part by part. 3x squared. I need a function where 3x squared is the answer. That'd be x to the 3rd. Good. Plus, good. 2x squared. That derivative would give you 4x plus c. I would write off to the side for this one. 1 over x to the 7th is really x to the -7th. And actually, before we do this one, you guys were kind of rolling through them, so I didn't want to slow you down. I'm going to stop us for a second, and I want us to go back and write down what you were actually doing. How did you get 1/4 x to the 4th? Like, let me slow you down and have you figure out what you actually did. You took the 3 and you did what? You add 1, and then you divide by that number. So let's just add that to our notes real quick. You're going to add 1 and divide. Because when you take a derivative, you multiply and subtract. So now you're adding and dividing. It's in remember socks and shoes. That's what I always bring up. You put on your socks, you put on your shoes, and you take off your shoes, you take off your socks. You're doing it in reverse order is what's happening. But that's what you're doing. You add 1 and divide. So when it's negative, it's a little tricky because when you add 1, it becomes less negative. So if you have -7, if you add 1, what are you going to get? -6. And then out front, you would need a -1/6 and then plus c. So negatives are tricky. When you add 1, they become less negative. Again, you can always do this derivative to check. You'll get what's there. I'm going to write this one off to the side as well. Cube root of x is x to what power? 1/3. Good. So we're going to do the same thing. It's just fun with fractions. You're going to add 1 and then divide by that. So 1/3 plus 1. Good. 4/3. Now out front, I guess you could put 1 over 4/3. But what's a different way we can write that that'll make it like just look a little bit neat? Like, don't write this. Like, I don't want that. That looks messy. How could I write that instead? Yeah, 3/4. Just do the reciprocal. All right, for this one, what is your power for a square root? Is 1/2, but this is actually going to be -1/2. Good job. Perfect. Negatives and fractions are the hardest thing ever. So I put a bunch of them on here. So you're going to add 1 to that. It's actually kind of good because if you take -1/2 and add 1, now it's +1/2. So now it's not negative anymore. And then what would need to go out front? Don't write this. I mean, like, that's not wrong, but it just looks awful. What should we put instead? Yeah, just 2. And then plus c. All right, off to the side. This would be 2x to the what? Negative, good, because it's in the denominator, and 1/4, because it's a 4th root. So we're going to ignore the 2 for just a second. You're going to add 1, which is actually a good thing because it's going to make it not negative anymore. So -1/4 plus 1 would be 3/4. That means out front you would put 4/3, and then I just leave the 2 there. I'm not trying to do it all at once. It's too much for me to keep in my head. I'm just going to erase it and fix it. 2 times 4 is 8, so 8/3. Trig, yay! I'm the only one who's excited. You need to come up with a function that if you did the derivative, you would get sine. Sine is the answer. Good. It's negative cosine. Because if you just left it as cosine, what's your derivative of cosine? Negative sine. So you need the negative there to cancel it out. Which trig function, and guys, look, there's only 6 trig functions, and I'll give you a hint. It's not sine or cosine. Which one out of the other 4 has this as its answer, as its derivative? secant. The derivative of secant is secant tangent. What's the derivative of tangent? Secant squared. All right, how about this one? We want cosecant squared to be the answer. I'll give you a hint, it is negative. It's one of the other ones. Cotangent, good. The derivative of cotangent is negative cosecant squared. You just need the negative in there. And then this is everybody's favorite. What's your derivative of e to the x? E to the x. So your antiderivative of e to the x is also e to the x. So this answer is 15 e to the x plus c. All right, how about for this one? X to the fourth antiderivative. Good. 1/5 x to the fifth. You see that a lot. 1/5 x to the fifth or 1/7 x to the seventh. Like you see that a lot. Minus e to the x plus c. Whoever said that before, you were just ahead. I need a function whose derivative is 1/x. 1/x is the answer. ln. Now, when you do ln, you need to put an absolute value around the x. I don't usually say that when I'm saying it. I just say ln x because ln absolute value of x is just such a mouthful. But here's the reason why. You can't ln what kinds of numbers. You can't ln negatives. So when you go backwards, you need to stipulate, hey, those numbers can't be negative. Just throw an absolute value. Now, that problem and this problem are practically the same thing, but the 3 ends up throwing everybody off. Remember, you can take numbers and evict them from the problem. You can write this way and take that 1/3 and just put it out front. Usually writing it that way helps everybody to see it a little bit better because it's practically the same problem. What would this answer be?
1/3.
Yeah, 1/3. And then we just did this over here. It's 1/3 ln x. Yeah. And you don't have to say absolute value. You can. I mean, we just have to understand that it's there. But yeah, 1/3 ln x plus